Question number 41. A disk freely rotates without friction at a certain angular speed about a fixed vertical axis normal to the plane of this disk and passing through its center. At time t equals 0, a spider vertically lowers itself with negligible speed into the rim of the rotating disk as shown in the figure and becomes rest. Variation of the magnitude of angular momentum L and angular speed omega of the disk only with time t is represented by. We have to consider the word disk only. We have to consider disk only. Then when spider landed into the system, its momentum, angular momentum is conserved for the system. But when considering disk, an angular momentum should be given to the spider and equal and opposite angular momentum should be decreased from the disk. Then when considering disk, angular momentum should be decreased at t equals 0. Then we have to consider angular momentum L value should be decreased. And when considering angular velocity, we know that I omega for the system is conserved. I omega conserved by landing spider into the disk. I value is increasing, then omega value should be decreasing. When I is increasing, omega should decrease. Then omega graph also should be like this. Then we can get answer is 3 for the question number 41. Then 42. Figure shows vertical cross-section of 3 uniform bodies A, B and C of identical masses. A is a solid sphere of radius r. C is a hollow where the radius r and having the thin walls. The spheres can be rotated about vertical axis passing through respective centers. B is a disk of radius r which can be rotated about an axis normal to the plane of the disk passing through its center. All figures are drawn to same scale. If KEA, KEB and KEC respectively are the rotational kinetic energies to be provided for bodies A, B, C to attain equal angular speeds, which of the following expression is true? When considering 3 bodies, there are same masses. And when considering mass spreadness is greater, is the greatest value for body C because of it is a hollow sphere. And then moment of inertia, mass spreadness is B is less than C and A is the smallest value. Then we can consider mass spreadness is A, B, C in ascending order. Then we can consider moment of inertia. Moment of inertia value also should be proportional to the mass spreadness. Therefore, we can write same order A, B, C in ascending order. And we know that kinetic energy, rotational kinetic energy is half I omega squared. When considering the rotational kinetic energy, we have to consider the angular velocity. But they have given that angular velocity is same for all 3 bodies. Therefore, kinetic energy also directly proportional to the moment of inertia. Then we can get kinetic energy order A, B, C in ascending order. KEA is the smallest value, then KEB, then KEC. We can get answer is 1 for the question number 42. Then 43. An air mass in a cyclotron moves around its eye in a spiral path as shown in the figure. The velocity of air mass at a radial distance of 80 kilometers from the center of I is 150 kilometers per hour. What could be the velocity of same air mass at the radial distance 40 kilometers from the center of the eye? They have classified this MCQ as a rotational motion MCQ, but it is not a rotational motion MCQ. We have to consider circular motion and magnetic fields when solving this problem. Whatever, we can use F equals ma for the air mass towards the center. Cyclotron is a particle accelerator. It is a circular particle accelerator. It is accelerating, it is increasing velocity by using a magnetic field. Therefore, we have to get this centripetal force is given by a magnetic force. Magnetic force is dQV. We have to study magnetic field to get this equation. D is magnetic flux density, Q is charge, V is velocity. Equals to M. We can write centripetal acceleration. M is mass of air mass. Centripetal acceleration is V omega over V squared over R. Then we can cancel out one V term and these terms are constant. Then we can get R directly proportional to velocity. Now at 80, they have given that at 80 kilometers radius, velocity is 150. We have to find the velocity at 40 kilometers. Then we can write 80 kilometers directly proportional to 150. We have to find velocity at 40 kilometers radius. I will consider it as V. Now we can divide two equations. Then 2 equals to 150 divided by V. We can get V value is 150 divided by 2, 75 kilometers per hour. 75 kilometers per hour is first answer. Then we can get first one is the correct answer for question number 43. Then 44. The figure shows a thin uniform rod AB of length L and mass capital M. Moment of inertia of the rod about axis PQ parallel to the rod situated at distance Y. When considering AB rod, all particles of AB rod is at a constant distance from PQ given axis. Therefore, we have to get moment of inertia is mr squared. We have to use directly proportional relationship, but we can consider that when considering rod, all particles of rod is always y distance from the given considered axis. Therefore, we can consider it as an object which is situated a constant distance from the given axis. Then we can get I equals M is the mass of the rod. It is given as capital M. R is the distance from symmetrical considered rotating axis to the object. It is y. Then we can get my squared is the answer. First one is the answer for question number 44. Then question number 45. Consider the following statements regarding the moment of inertia of a body. Part A, it depends on mass of body. Yes, we know that moment of inertia is I omega squared. Mr squared. Then it is depending on mass. A is correct. Then statement B, it depends on mass distribution of the body. Yes, it is depending on mass distribution. It also correct. Then part C, it depends on angular velocity of the body. No, it is not depending on angular velocity of body. Then only A and B are true. Then answer is 3 for the question number 45. Then question number 46. A block placed on a horizontal frictionless table is attached to the mass M by a light inextensible string that passes over a pulley as shown in the figure. When released from the rest, mass M and pulley accelerate if the tension in the section in the string are T1 and T2 are marked. Which of the following is true? You know that when considering object, simple M mass, it is accelerating. Simple M is accelerating downward. It means mg weight should be greater than T1 tension. Mg should be greater than T1 tension. If this object is accelerating, tension, this T2 tension should be always less than T1. Because of they have given that pulley should rotate around the axis because of when released from rest, mass M and the pulley accelerates. Pulley is accelerating. It means pulley should rotate around the axis. Therefore, tension in these two parts are different values. Pulley is rotating in this direction. Therefore, T2 is smaller than T1. Then we can get answer is 5 for the question number 46. Then question number 47. A flywheel of moment of inertia 0.4 kilogram square meter is rotated with uniform angular speed of 10 radians per second by a motor of power 100 volts. When the motor is switched off, the angular deceleration of the flywheel is. Now we can consider 47. You know that torque is work done is torque into angular displacement. For the linear motion, we know that work done is force into distance. For the angular motion, work done is torque into angular displacement. We can divide both sides by time to get power. Work done divided by time is power. It is equals to tau. Tau means torque multiplied by theta over t is angular velocity. Now they have given that power is 100 watt. Tau value we have to find it. Omega is 10. Then we can get torque is 10 radians per second. 10 Newton meter. Then we know that torque given by the motor is 10 Newton meter. Now the object is not accelerating. It means it has a uniform angular velocity. Therefore, the net torque on the object should be 0. It means there is an equal and opposite frictional torque on the object. When the motor is switched off, there is only one torque. It is frictional torque. Therefore, we can consider frictional torque. It also should be equal to 10 Newton. Then, when considering frictional torque, we can use tau equals I alpha in the opposite direction of movement because of frictional torque is acting in the opposite direction. Now torque is 10. Moment of inertia is given as 0.4 into alpha. We can find the alpha value. Alpha means angular deceleration. 100 divided by 4, 25 radians per square second is the angular deceleration. Then we can get third one is correct answer for the question number 47.